Kia ora and welcome to this Manaaki Whenua LINKOnline Webinar. My name is Tiffany and I'm the Senior Marketing and Events Advisor here at Manaaki Whenua. I'm stepping in for Christine while she has a well-deserved break. Today we have David Whitehead and Sam McNally introducing you to a new collaborative MBIE Endeavour Research Programme, Trees and Landscapes, Te Kapunipunitanga a Tāne Mahuta. The aim of this program is to investigate how mosaics of tree clusters across low to mid-slope grasslands can achieve carbon sequestration, but also allow grazing to continue and provide added benefits and value for rural communities. David and Sam are co-leads of the program and will give you background on the research idea, their plan for the next 4 years, and how you can help them with site selection and data. I'll be back at the end to help you with your questions, so don't forget to put them in the chat box as soon as you can. Over to you, David.
No mai, haere mai, and thank you all of you for joining us. Much of our moderately to low sloping agricultural land at present is used for sheep and beef farming. But the question we're asking in this program is, can we change that land use to enhance the economic, the environmental and the cultural benefits for the future? Is this the appropriate model to continue with sheep and beef farming for these landscapes? There's been considerable debate about mitigating greenhouse gas emissions by storing carbon in biomass. And there's been strong recommendations about converting much of this low productivity land of grassland into forest. And it's often associated with monoculture pine plantations. Landscapes that might look more like this are being proposed. And of course, we see a lot of those already as we travel around the country where there are blocks of pine trees. Now, pine trees have their place, and it's right that there should be continued plantation establishment. But are there better ways to achieve the mitigation of greenhouse gas emissions and the other co-benefits and enhance those as well? What we're proposing that the integration of mosaics of diverse groupings of clusters of trees across the landscape is a future model to go. And we're arguing that for the same land area, we can achieve greater carbon sequestration in both the biomass and the soils, but we can also provide considerable co-benefits. And this is all because of the edge effects associated around the clusters of trees. And this is where the focus of our program is going to be about. Around the edges of trees, there is going to be, the environmental conditions are different for light, temperature, water, and nutrient availabilities. And this results in changing carbon inputs from trees into the soil, and also changes root exudation from trees into the soil rather than grassland into the soil. These processes all affect the microbiology. They affect the whole carbon and nutrient cycling in the system. And we, based on evidence internationally, but not yet tested in New Zealand, we're arguing that these complementary effects are associated around the edges of trees, and they lead to enhanced carbon stocks and other benefits as well. But of course, critical to this is matching the trees with the right traits, the soil type, and the climate. So we might see a lot more landscapes looking more like this into the future, where trees are integrated into the current grazing systems on our mid-moderate to low sloping hill land. Now, we are going to present the concepts of the program to you today, which is just underway. We don't have any findings to share with you yet, but we're hoping, of course, that in the future that will be the case. So our program, Trees in Landscapes, Te Kapunipunitanga Tāne Mahuta, is now underway, and this is where we're going to tell you about this morning. The critical issues that we aim to address for this program is about helping New Zealand to reach its carbon zero target by 2050. We recognise that tree establishments is critical for offsetting greenhouse gas emissions, and the Climate Change Commission has recommended that we should be planting 680,000 hectares of new forests by 2023. Well, trees already exist on farms, but many of them are isolated in gullies and steep slopes to reduce erosion. There are large areas of hill country available that could be available for the cluster planting that we're talking about. We know that there will always be the case for plantation forest, but there are some areas where we're looking at alternative land uses. At the moment, there is also the policy is that it does not allow farmers with woodlots, isolated trees, small clusters to account for carbon stocks. And so that's an area which we're approaching as well. So our work is all about integrating the same area of multi-functional diverse groupings of trees with the focus on the edge effects. And at the bottom of this slide, we show some of the points of knowledge gaps which exist. We don't know anything about edge effects in New Zealand. We don't know how to match some soil type with climate and soil and tree type. There are very, very large uncertainties associated with soil carbon measurements, and we need to be able to extend these findings to the landscape scale and take into account Maori aspirations and priorities. These are some of the benefits that we see associated with the establishment of tree clusters in the landscape. The benefits in green at the top are all about increased carbon storage. In the yellow ones are about new commercial opportunities that planting of tree species could provide. The blue ones the blue one there is about increasing the resilience of farm systems associated with all the co-benefits that might come from these clusters around the landscape. We've also included some orange factors there, which are not actually being covered by our program. The reason is that they are already being covered by other programs that are existing, but also we have to put limits around the amount of research that we can do over a 5-year period. So they will be covered elsewhere, but we will not be addressing them directly in our program. And finally, the light blue co-benefits at the bottom really are all social, cultural aspects that will help maintain and improve livelihoods in the rural sector. We see all of these occurring. Now, we have had an attempt to define and calculate the benefits associated with these tree clusters. And what we have done here in this is looking at the opportunity to present to establish 170,000 hectares of trees, which is essentially 25% of the area that's recommended by the Climate Change Commission, and over a 30-year period. So what this figure shows is a comparison between grassland as the baseline, permanent forestry, and on the right-hand side, the cluster systems that we're talking about. So international studies have shown that biomass carbon is increased in clusters relative to permanent forestry. Some international studies have shown very, very high estimates of increased biomass. Let's assume for this calculation that we're looking at 24% increase, which is we argue is a reasonable increase. When we look at soil carbon, the present inventory says that after 20 years, soil carbon stocks will reduce by 13% under plantation forestry. We're arguing that that loss will not occur in relation to the tree clusters because of these edge effects that we've talked about. And we're suggesting also a modest increase of 10% in terms of soil carbon stocks. There's also methane reduction from animals. There'll be fewer animals at the site. Grazing will continue, but there will be a reduction in methane emissions associated with that. So if we look at the carbon stock change, the methane reduction carbon equivalent, then we estimate in terms of billions of dollars that there is substantial difference in relation to the cluster scheme that we're discussing, proposing, rather than plantation forestry. Now, this analysis does not include profitability from animal or forest products, but they will be considered in future aspects of our program. But the overall benefits are clear from that first attempt to assess what they are. So how are we going to go about this? Well, there are 4 components to our program, and these are research components that span the scale from soil microbiology right up to landscapes. There will be components associated with measuring the biomass and soil carbon stocks, field measurements, looking at the actual what is happening at different sites. And these measurements will be used with a lot of other detailed measurements to look at what are the processes regulating soil carbon turnover, and predictive models will be created in order to assess those. We increase in scale when we look at the landscape scale. How can we scale the findings to landscapes to design landscapes with the maximum benefits and the economic valuation of these adoptions? Now, I'm going to ask Sam to explain to you a little more about these details in a moment, but let me just show you what the outcomes of this program are going to be. The land manager awareness of the opportunity is clearly higher on the priority list. We're interested in talking to farmers about the barriers to adopting these techniques. We aim to inform landscape design and, of course, inform emissions reduction policy in relation of greenhouse gas emissions, enhance Kapunipunitanga, and ultimately we expect this work to move towards designing resilient agricultural systems, but helping New Zealand to reach its carbon status of carbon zero by 2050, and possibly a blueprint for future landscape design. And I'll now pass over to Sam to continue.
Thanks, David. As David mentioned, this program has 4 main research areas, which are all interconnected and range from the microbial scale right up to landscape scale. So research area 1 is led by Scott Graham and Catherine Tozer of Ag Research, and it's primarily focusing on the quantification of carbon stocks and biomass from vegetation and soil carbon. It also includes some forage quality indices and how these change along the transition between trees and grassland. This work will be carried out at 32 sites that differ in soil type, vegetation and climate. And we will use transects that run from within these true groupings out into the grassland with a specific focus of near the edge to allow us to quantify that edge effect, as David's mentioned. So in this little diagram or animation here, each point along the transect would represent a sampling point where we collect a whole range of data. The next slide, please, David. Research area 2, which is led by Cara, Ellen and myself, is moving more from the field and into the microbial modelling. This research area would aim to focus on modelling carbon stocks using a microbial explicit model. And this will allow us to run scenarios that explore the effect of adding different vegetation into carbon, or adding different vegetation types on the carbon stocks. So we could go out and plant a whole range of different vegetation types into soils and climate in these combinations, but this will take a lot of resource and time. So using this model, we're able to do this more efficiently and explore additional scenarios such as the impact of future climate. Another key area of this research aim is to use metagenomic analyses to determine microbial function and how that function changes when trees are planted into grassland. So the big aim here is that we want to incorporate this metagenomic information into our model to improve our prediction of these carbon stock changes within our landscape. Next slide, please, David. RA3, or Research Area 3, is led by Dan Richards and Alex Herzig, and this is centered around scaling and optimizing our landscape. So we acknowledge that there's many possible futures for a landscape and many ways that we could establish trees within a landscape. For example, there's different tree types you could plant, arrangements, designs, patch sizes, etc. So by using simulations, we can project how these different scenarios can impact both carbon stocks and the range of other co-benefits. And so with this information, we plan to be able to design landscapes to maximize these benefits while meeting the farmers or landowners' objectives. Next slide, please, David. And then finally, in our research area 4, this research area is led by Max and Polakov and Nikki Harcourt, and this is where our economic, social and multi-centred research sits. So for our economic and social work, we're going to value the benefits and costs at the landscape scale and explore the likelihood of adoption and trigger events, which might help to change management practices. For the multi-centre research, we're going to actively engage with our Māori communities to understand the aspirations and priorities. So for this, we have a kāhui that represents the diverse views within Māoridom, and this will help make sure that we represent these different aspirations and priorities. So one of the key aspects of this work is to balance our environmental concerns with economic opportunities to enable these communities to thrive. So that's just a real high-level summary of those 4 research areas and gives a taste of the breadth of work we're doing, but there's obviously a lot more detail behind each research area. So I'll hand back to David now to continue on with the last bit. Thanks, David.
Thank you, Samuel. That was a very brief overview of what we're doing, and we hope that you'll follow us in future when we're able to sort of tell you more about our findings and how they're starting to come together. But we're also interested in asking for your help to make this program successful, keep it relevant, and also the quality of science to make sure that that answers the questions which are really important. So how could you help us with this? Well, if you have established groups of trees on your farms, then we're keen to hear from you. And now we do have certain criteria, and we can let you know about those. But essentially, we're interested in your experience of using trees on farms, and we would like to engage with you on those bases. As Sam mentioned, we're looking at 32 sites across the country to measure at, and we can measure several different clusters of trees at each site. But we're interested in your help in finding these sites where we can work. We clearly need to have some strategy behind, well, we have a strategy behind how we're going to do the selection, so they're not all the same trees in all the same places on all the same soils. But we are interested in knowing about the opportunities across the country. We have databases, of course, which will help us to identify soil types and climate. And so we can actually do quite a lot of preliminary work before we actually would possibly come and visit your site and see if we were able to make some measurements there. But we will be using a wealth of information that we've already got about these sites before we approach them. If we could, with the sort of measurements we're talking about, and if you're interested in working with us, then we would come to your site. We're talking about making non-destructive measurements of the vegetation of the trees and the grassland along those transects, which Sam pointed about, not interfering with operations or doing any destructive work at all, but taking lots of samples back for us to analyze in the laboratory and lots of on-farm physical measurements. We'll also be asking farmers and landowners to participate in surveys about their attitudes towards the benefits associated with trees. And ultimately, of course, we will always share data on an anonymous basis with individuals, and we will be able to bring all these data together to participate in the findings and the synthesis of all of the work from all these different sites. Additionally, I mentioned there were areas of research which we do not have the capability to look at. Particularly biodiversity aspects is one big area which we're not able to focus on, but we would appreciate anyone who's interested in coming to do additional research, maybe collaborating with us at these different sites, but doing additional research to be able to make more of what we have already. So please contact us there. I would like to re-emphasize this is a very large multidisciplinary program with a strong research team. We have the research providers on the right-hand side from New Zealand and our international providers as well. But we also are very, very appreciative of our end users on the left-hand side who are advising us and informing us about the relevant, to ensure the relevance and contributing their experiences as we develop this research program. We have a website there at the bottom there. Please go to that to find out more details, and we will update, of course, as more comes in. And we have our contact details there on the right-hand side. So please contact us if you'd like to progress any opportunities with us. Thank you very much.
Thank you, David and Sam. That was great. And you've left a lot of time for questions, which I'm sure the audience is very excited about because there are a lot of questions to get through. But I might just jump in first and ask my own question. So how will you decide on which tree species to plant and where to plant?
Well, thank you. I have a answer, and then Sam can come in afterwards. That's a very major question about can we advise farmers about which tree to plant and where to plant it. A lot of our work will be based on the complementarity between the tree type, the soil type, and the climate. They are essential for deciding which trees are appropriate. How is the tree going to modify the carbon inputs? So if we look at a landscape such as that in the photograph there, we would want to analyze for the soil type and the climate, and then match the tree species to it. So we're not restricting ourselves to any particular types of tree species, but we would want to do work to match, and that's critically important for us, so that we will be able to provide scenarios of matching the right species in the right places.
Great. Our next question is, what is the size, so the land area per cluster of trees that you're looking at?
Sam, you might like to answer that question, please.
Yeah, sure. That's a really good question and something that we're still probably grappling with ourselves. But we are tending to think of currently the ETS doesn't recognise less than 1 hectare in size. So we're kind of thinking of clusters that kind of would be under that criteria initially, where you could sort of dot them around the landscape. But yeah, that's going to be a part of our work, is to try and figure out, particularly with the landscape scaling work, is what was the best patch or size of trees that we should plant. So something that we'll be considering.
Thank you, Sam. Are you considering how this approach could integrate with the sequestration strategy that will be developed as part of pricing on farm emissions, or are you just looking at eventual ETS eligibility?
Well, the answer to that, I think, is that we are advising and informing policy, and policy will do that part of it. But if we can inform policy in terms of what rates of sequestration can be, and we can also reduce uncertainties associated with measuring and estimating soil carbon stocks and biomass stocks, then we will be inputting that to policy advisors to make those decisions.
Great, thanks, David. So on that, could you elaborate on the likely factors that lead to increased biomass sequestration created by the edge effect? So is this a function of increased branching and different tree forms for edge trees?
Yes, I think in relation to that question, we haven't talked much more about branching patterns and what have you, but clearly when you move around the edge of a cluster, there's a far more foliage down to lower levels because it's exposed to the light. So we believe there are strong environmental effects of increased light interception and possibly nutrient and water availability as well, which add to that. But we're also arguing that the soil microbiology is a big important aspect of this study, and that, of course, is all to do with how trees gain nutrients and how they have access to water, and how the cycling of carbon and nitrogen is occurring.
Will you look at the impacts of fencing blocks of trees on biomass, soil carbon, etc.?
Sam, would you like to answer that?
We haven't specifically got that as a criteria, but we'll inevitably have some areas that will, when we sample, that will be fenced and unfenced. So I guess it's not a specific objective, but we are going to probably touch on that slightly through our sampling, because there'll be areas of trees that are already fenced off from the pasture, and then ones that don't have any fencing as well. So I think we'll be able to kind of get at that question a little bit.
This one, understand that biodiversity is out of scope for your study, but will you be including a range of native forest types in your study and contrasting them with different exotic types like monocultures or multi-species communities?
Yes, we have got no sort of fixed ideas about the species that we're going to be using, other than we need to have a range of species with different, we call them functional types. Conifers and broadleaf foliage, of course, has very different characteristics, such as carbon-nitrogen ratios. And we want to ensure that we cover a range of carbon inputs from foliage, which is deposited on the ground and goes into the soil. But we do intend to work with a range of different species, whether they are conifers, or whether they are native conifers or native broadleaf, or whether they are production species. Catherine Tozer, who works with us, has a lot of experience in tree lucerne and fodder crop trees, so we're interested in those as well. And we're also interested in agroforestry. There's been much of these studies in Europe and North America have come from silvopastoral systems, or agroforestry systems, whereas agroforestry systems in New Zealand are not that popular, it seems. But we also argue that there's a possibility that they could be very beneficial in capturing a lot more of these benefits.
Thanks, David. Will the modelling or measurements look at the effects of shadowing by trees on adjacent pasture quality? Will the water needs of the trees impact adjacent pasture quality?
Yeah, I will ask Sam, your expert on that, please, Sam.
Yeah, I guess the modelling will compare the scenario between like the trees and the grassland, but one of our colleagues does have experience like modelling shading effects and stuff as well. So whether we can bring that in scope, that's a possibility. But yeah, definitely something we're considering, and particularly with Catherine, as David mentioned before, that there's forage quality indices along the transect, we will get to some extent the effect of, as you go from within the cluster out into the grass, and the effect on that pasture quality. And so I think we'll be able to answer those questions quite well. Yep.
Great, thanks, Sam. I think we'll be able to fit a couple more in. So is there potential for the scenario modelling to somehow be incorporated into farm environment planning, for example, to predict how specific plantings will impact on specific farms?
Yeah, Sam, you'd like to carry on about that because you've been working in that area.
Yeah, I guess that's a big question. I think we first have to kind of show the benefits and what we can achieve before you can kind of look at that. But I guess the ultimate outcome is that you can start giving the information to landowners and farmers to be able to change their land use or to do these and get credited for it. So yeah, it's an interesting question. I think something that will be at the back of our minds, but I think we've got to do the research and stuff in the meantime before we get to that point.
Great, thank you. We'll finish with this last question before we wrap up. So how do you envision this work adding to the opportunity for agroforestry?
Oh, thank you. I mentioned that earlier. Yes, I think we are very open to including agroforestry areas in our analyses. They are a sort of unique opportunity to look at spaced trees where there is also grazing as well. And although they're not as popular in New Zealand as they are in some other countries, we believe there's opportunity there. So yeah, we will definitely want to include agroforestry.
Great, thank you. There are a lot of questions, so apologies we couldn't get through them all, but I promise you we will, not me, David and Sam will deal with these offline and we will come back to you with an answer. So many thanks, David and Sam, for a great presentation. Tomorrow, actually, an invite for our next webinar will be sent out to you on Māori Frameworks for Disaster Recovery and Climate Change, presented by Dr. Sean Awatere. Thank you everyone for joining us online this morning. Ka kite anō.